All right, let's go ahead and get this started. So again, today we are going to be going over the review from the textbook. So if you have your textbook handy, again, you could just follow along with those. I did add a spot to submit the assignment from Friday as well. Let's go over a couple things real fast. So we have a test coming up this Friday. So again, here's our calendar. Again, the one thing from this calendar, I made the changes on the calendar that happened last week. So again, the only thing that we covered last week that will not be on the test is the stuff from the density that we covered on Friday. But again, there is still the assignment that I had gone over on Friday, and I posted a spot for that today, as well as a spot to submit the notes. So if you have not done the notes yet from Friday, again, there's still a requirement. There's still something that you need to submit. So there's a spot on Edsby to submit those now, as well as the assignment from that day. So today we're going to be taking a look at the review from the textbook. So again, it's from pages 511 to 513. So if you have your textbook, again, I would recommend just having your textbook out instead of printing off all the slides. I didn't even post the slides to be printed since everything can be found in your textbook. I will post the slides afterwards though, as well as we have another review that I'll post. Actually, I'm going to post two more reviews. I'll probably post them later today. So similar to the review that we had last time where my department head made the review, she made another review for this section, and she also already made videos for them. So I'm going to post both her review and the video for it on Wednesday. I'll go over any questions that are on the review. So again, there already be videos posted, so I'm not planning on going over every single question on Wednesday, just any particular questions that you want me to go back to. So again, all those videos will already be posted on Edsby and on YouTube, so you'll be able to see those starting later today. For the extra credit review that I have here, I'll also be posting that today. It's basically just extra practice doing volume, surface area, lateral area. It's going to look very similar to the worksheet that we had that had all the formulas on it. So just be checking Edsby for those things later today. And those are the things that I do later this week. Oh, let me go back to this. So again, the test, it's this Friday, but again, just like last time, I'll open it up so that's open from Thursday through Sunday. Again, take it whenever you feel comfortable taking it. The following weeks, so there's going to be 2 weeks left after this week. So we have 3 weeks total this week. And then these last 2 weeks, we're not going to be doing any new geometry material. And I'm not really going to be giving you any assignments that would hurt your grade after Friday. So again, that test is the last thing that will be the main focus of your grade. But then there's basically 2 weeks to either catch up, and then there's going to be the 1 week I'll assign some algebra worksheets as well, just on algebra skills. I'll still be coming on to do my office hours. So I'll sign on at the same times that I always do. I'll be on here so that if you have questions or need help with something, you can log on. I'll be on Zoom during those same times. So again, all the same times that you've had all along. Notice though, on this week, instead of having it from 10, like today, where we normally do our Zoom from 10:15 to 11, I have it from the entire time, 10:15 to 12. I'm going to have my office hours these last 2 weeks open to both my classes, so Geometry Honors and MSCS, because again, if anybody has any questions, they can log on during that time. I'm not doing an actual class. I'm not doing a normal class during those last 2 weeks. So again, those you will see, again, just like regular office hours. So if you ever stop by and ask me questions during office hours, it'll be the same thing for those last 2 weeks. But again, though, I'll have this schedule posted as well afterwards. A couple of you guys that just had logged on in the last couple of minutes, let me just go back to this. Again, remember, we have a test coming up this Friday. The other things I said, just to recap, Wednesday's Zoom is just going to be to go over questions that you guys have that haven't been answered already. So like There will be that video that goes over the review as well as answer keys posted. So make sure after you do the test review to check your answers, to watch the video. Again, that stuff will be posted later on today. All right. Also, Friday Zoom. Fridays will be just regular office hours this week. So again, since we have a test that day, again, it'll be regular office hours. Okay, things that you should have when you go to take the test. You definitely need this page, right? So if you haven't printed this out at some point, make sure you go and print this out. If I've included this on every single slide that we've done, I've included it at the very beginning. There's a separate folder that says formulas in the OneDrive folder. Again, I'd have this printed off from one of those things. Again, it was originally uploaded as both a PDF, a picture, an actual Word document. So again, you can print off whichever way you want to print it, but it's there. This was also from the very first chapter, Euler's formula. That was one that you needed to know for this section. So number of faces plus vertices equals number of edges plus 2. That was from the very first section. That will be on the test. The density stuff, again, density, displacement, similar solids, this will not be on the test. So again, you don't have to have that one for this. Now, could I ask you questions involving like a population density type thing? Yeah, so there were a couple questions involved with density, but again, I don't remember seeing any questions with any type of density on the test, truthfully. This was the assignment from Friday. So again, if you haven't done the assignment from Friday, make sure you get that done and turned in by tomorrow. And now let's go ahead and start this review. So the textbook review, again, if you have your textbook, all the questions are coming from page 511 to 513. We're starting off on page 511. So the first question there is, how is Cavalieri's principle helpful in understanding the volume formulas for solids? So something that you need to understand is that when we talk about those volume formulas, it's just adding in that third dimension. So Cavalieri's principle breaks down a solid into two-dimensional planes, and it talks about how as long as the volume, the area at every single level is the same in the shape, then those shapes have a similar volume. Essentially, we're just taking the area and kind of multiplying it by whatever the height is in order to come up with that volume. So again, just a little explanation on that. That's what number 1 is looking for. You don't have to write it all out. From 2 on, again, you should make sure you write your answers down when you submit your responses for 2 on, but again, you don't really have to do number 1. For number 2, a prism is blank if one or more faces is not perpendicular to the bases. So, well, this would mean if it's not perpendicular to the bases, that means that instead of it going straight up and down, it's slanted. So that would be an oblique solid. So on here, oblique would be our first answer. So let me find my mouse here. There it is. All right. So oblique. Now, number 3, describe the relationship between the volumes of three-dimensional figures that have the same height and the same cross-sectional area at every level. So, like describes the relationship between volumes of three-dimensional, same height, and cross-section at every level. Well, that would be Cavalieri's principle. So, top answer there. Again, if the area is the same at every single level and the height's the same, then the figures must have the same volume. Okay, you can't really fit that all in that one space. All right, on number 4, a great circle divides a sphere into 2 hemispheres. Again, the great circle is the one that goes through the middle. There is a definition back in the section on spheres. But again, a great circle divides a sphere into 2 hemispheres. So again, great circle, biggest circle in a sphere. Oh, that's on that. And it's divided into 2 hemispheres. Think of the Earth. The Earth is divided into a north and south hemisphere by the equator. The equator would be an example of a great circle. Or you could also do it vertically, but again, makes up a couple different lines there. All right. Any other questions on those vocab words? All right, moving right along. Okay, on the next part. So now this is from section 11-1. So we had a couple things in that section, including Cavalier's principle, rotational solids, and then using the formula for Euler's law. So on here, number 5, the pyramid has 6 vertices and 10 edges. How many faces does it have? Now, over here they gave us a picture, but again, we shouldn't have to count on that picture. We should be able to figure it out with the formula. So let's pretend they didn't give us this. So again, the formula is faces plus vertices equals edges plus 2. So if they told us that the number of faces is what we're looking for, the number of vertices is 6, the number of edges is 10, we'd have f plus 6 equals 12. Subtract off 6. The number of faces must be 6. Now again, looking at the figure, we can verify that. We had a pentagon as the base. So we had 5 triangles that were coming up from the pentagon to meet at common vertex. So the 5 triangles plus the 1 base that was the pentagon would give us a total of 6. So again, this formula works every single time. Number 6, visualize a plane intersecting the pyramid parallel to the base. Describe the cross section. So again, on our figures, if you have a plane intersecting any one of our figures that were either the pyramid or the cone, you're going to have the same shape as the base, except it's going to get smaller as it gets closer to the vertex at the top. If you had a parallel plane to the base on either a cylinder or a prism, it'll be the exact same shape as the base, and it'll be congruent to the base. So on this one, it'll be the same shape as the base, but it will be smaller than the base. So it'll be a similar figure, but smaller. You could even say it would be a dilation or a reduction of the base. So let's say, since we know our plane, our base was a pentagon, let's say a regular pentagon that is smaller than the base. Again, that'd be an easy one. Again, if you wanted to be more technical, it'd be a reduction. It'd be a similar figure. It'd be a reduction of the pentagon. All right. Number 7, describe the 3-dimensional figure that is formed by rotating the rectangle about the line shown. Well, if we were to rotate this around the line, so again, anytime we're rotating, it's going to give us something that's curved. So again, it has to have a circle as the other side of it. So if we picture this being rotated all the way around here, and we picture this side being rotated all the way around here, and we fill it in, it is a cylinder that's on its side. All right. So it is a cylinder. Number 8, can a polyhedron have the same number of faces, edges, and vertices? That'd be impossible because we have this formula. Faces plus vertices equals edges plus 2. And this has to work anytime that we have any type of polyhedron. So we could never have the same number of faces, vertices, and edges. It would never work. You could have the same number of faces and vertices, but then the edges would always be different. All right. And again, this is a good example of that first problem we did, because we had 6 and 6 for the faces and vertices, but the edges ended up being only 10. All right, so no. And again, if you wanted to use a reason, you could use Euler's law. All right. Moving on. On the next set here, now we're looking at 11-2. This was volumes of prisms and cylinders. Now, the thing you gotta remember about this review is this review is focusing on volume. I'd say that the biggest chunk of your test comes from the volume stuff, but there is some surface area and lateral area stuff on there. So again, you still need to use those formulas as well when you're on the test. So again, today's review is only focusing on volume because that's all that was covered in our textbook. Wednesday's review, or the reviews that I'm posting today, will have the other stuff on it as well. So for this first one, for examples 9 and 10, find the volume of each figure round to the nearest tenth. So number 9, we have both of these, 9 and 10, are both cylinders. So our volume formula for a cylinder, again, base area times height. We can also change out the base area for a formula for a circle, pi r squared times height. Now, do we have everything we need for both of these? More or less. So on the first figure, we have the diameter given to us. We need only the radius, so we need to cut that in half. So the radius is 15. This up here was the diameter. On this one, we have 3 is our radius, and then on 9, 70 is our height, and on 10, 8 is our height. So we have the values that we need to plug in. It says round to nearest tenth, so we're going to round. We're not going to leave in terms of pi. Again, for the test, you might be asked to leave in terms of pi, or you might be asked to round, so make sure you pay attention to any directions. All right, we have, for the first one, plugging this in, volume equals pi is 3.14. The radius was 15, so times 15 squared, times the height, which was 70. So now we're just multiplying it all out. 3.14 times 15 squared times 70. $49,455. That would be our answer. All right. Now, number 10. Number 10, again, same type of thing. Volume, same formula. Again, we're plugging in 3.14 for our pi, since it's asking us to round. Our radius on this one was 3. And our height was 8. So again, plugging everything into the calculator one more time. 3.14 times 3 squared times 8. And that gives us a total of 226.08. Now, the last one I didn't have to worry about rounding to the tenths place because there were no decimals left. This one, I need to round because it's not quite there. And in fact, remember, these are still rounded answers because we use 3.14 for pi. So round this to the nearest tenth. This is going to become 0.1. So 226.1. Other thing that I didn't do on either of these problems yet, you need to make sure you include your dimensions. So, sorry, your units, I meant to say. So we have millimeters cubed. That was supposed to be an M. And this one was yards cubed. All right, on number 11, what does the expression 3/4 x, y, z represent for the prism shown? Well, on here, let's see, 3/4 x, y, z. I'm going to guess it's probably the volume. Let's see if that works out. So volume for this one, V equals base area times height. Again, our base on this one is a triangle, so we're substituting in our formula for area of a triangle, 1/2. 1/2 base times height of the triangle. And again, we still have times height of the prism. So plug in the values we need. We have 1/2. The base of the triangle is 1/2 as well. More like 3 than 2. Let's try that again. The base was 1/2 z. The height was 3y. And the height of the solid is x. Now if we multiply these together, we have 2 times 2 is 4. That gives us the bottom number of 4. 3 times 1 times 1 gives us a 3 on top. Then x, y, and z. So Yep, it is the volume of that figure. Number 12. Let's see, it says we pour wax in molds to create candles. Compare the amount of wax each mold holds. So, first thing I notice here is we have 18 for the height on both of these. So, the height's going to be the same for these. All right, let's look at the base. So, on the base, we have 21 and 7. So, this is going to be 21 times 7. The base of this 7. 21 times 7 is 147. All right, let's come over here. Now, they gave us some unusual values if we're looking at this as a hexagon. But what they did, you'll notice they drew this red line in here. See the red line? Well, that red line actually represents a split of a hexagon into 2 trapezoids. Answering a question in the text, yes, I said that volume is a good chunk of the test, yes. All right, so on here. So again, this is splitting it into 2 trapezoids. So let's bring back that formula for trapezoids. Remember our area formula from trapezoids, and there's more than one way you can do this problem. So again, this is the way the book does it. You do not have to do it this way. 1/2 base 1 plus base 2 times height. That was our formula for area of a trapezoid. And I'll show you a second way that you could do this, but on this problem, 1/2 base 1, we can say is 5. Base 2 would be the 16 across. And the height, well, if we look at this, 14, that's for both of those all the way across. So half of that would be 7. All right, now we have 5 plus 16. 5 plus 16, that's going to be 21. 21 divided by 2 is 10.5. So we have 10.5 times 7. Oops, what did I just do? 73.5. Now, that's not our final area for the entire base because that's for one of those trapezoids. We need to double that to get both trapezoids. So times 2 gives us 147. Let me restart this computer because I'm experiencing some serious lag with this today. All right, 147. All right. Well, wait a minute. That 147 and this one had 147. So the base area was exactly the same. Well, the base area is the same, and these are both prisms, and the height's the same. Well, then the volume must be the same. So on here, what do you know about the amount of wax each mold holds? It is the same. And why do we know this without doing the entire problem? Because of Cavalier's principle. It is the, man, this is not writing very well at all. I don't know if my battery's dying or if, let me try writing that again, see if it, well, let me move my keyboard out of the way. Maybe that's interfering. But it's the same volume. It is, well, that's actually right there, the same. So again, the reason why that we can say it's the same is because of Cavalier's principle. If you have the same cross-section area all the way up and the same height, then the figures must have the same volume. All right. Any questions there? Now, I did say you could do this one more than one way. I did the trapezoids because that's how the book did it. It showed it cut into 2 trapezoids. You could also use your formula for a regular hexagon there. and it would also work. Right? But again, that would just be another way of doing it. All right, let's go ahead and move on. So for this one, the volume of a pyramid is, okay, and they give you the equations over here so we can use them. Again, it's the same formula for both a pyramid and a cone. So we're doing 1/3 base area times height. Again, same thing that I've said numerous times. Oh, let me go back to the other screen. I did not correct this on the other screen. Again, the one thing I don't like about this section in this book is they use that little h, and it should really be a big H, because again, we're talking about the height of the solid, and that's one thing that this book doesn't do that most other books do. So again, use a capital H when you're talking about the height of the solid, because it makes a difference when you're inputting other formulas in for your base area as well. So again, those should all be capital H's. And same thing down here. All right, now number 13 and 14. Again, using the formulas that they gave us, 1/3 base area times height, we have to look at to see what is the shape of the base when you do this though. So for number 13, I'm gonna use some of this blank space off to the side. So I'm gonna do 13 here. I don't think I had enough room. For number 13, we have 12 by 4. So for our base area, we're doing that rectangle, that's a 12 by 4. If you wanna find that first, you could. So we could say, all right, the base area here is 48. All right, so now when we go to plug it into our formula, we have 1/3 the base area, which we already know, times the height is 7. So again, there's more than one way you can use these formulas. We have 1/3 of 48 times 7, so 48 times 7, and then divided by 3 is 112. So the volume of the pyramid is 112, and this is, again, cubic inches. All right, on number 14, we have ourselves a cone. Yes, it's an oblique cone, just like it was an oblique pyramid. It doesn't matter. It's still the same idea. Again, whether it's a right cone, an oblique cone, a right pyramid, or an oblique pyramid, it's still the same equation every single time. So this time, again, for a cone, our base is a circle. So I'm going to plug all the values in, but I'm going to replace the equation, the big B, with our equation of a circle. So we have pi r, which is 15 on this one, squared, times the height, which is 24. Now, it says round again, so we're going to have to replace pi with 3.14. I would just plug the whole thing into the calculator. 3.14 times 15 squared times 24, and I'm saving the 1/3 for the answer. I can just hit divided by 3, and we get 1801.046. That's continuous. Again, we're rounding to the nearest 10th, so that's 1 decimal place. So this would be 1801 point, well, it's actually 0.0, so we could just round it to 1801. That would be our volume. All right. The first one, number 13, didn't have to round it. Again, just because it tells us to round, if it comes out to a whole number, you don't have to round it. All right, on number 15, a sculptor cuts a pyramid from a marble cube with a volume, and it doesn't actually give us the dimensions, but it says t to the 3rd. The pyramid is t feet tall. The area of the base is t squared feet. Write an expression for the volume of the marble removed. All right, well, you don't have to do any work on this one. They told us what the volume of the original one was, and they told us, well, if this is t cubed, that means that all the dimensions of the cube are the same. So it's t by t by t. And we can see that they have the base is the entire base for the pyramid. So t squared, that would have been t by t for the base. And t tall, well, the height's the same as in the original cube as well. So if we're just taking a cube and changing it to a pyramid, the pyramid's volume will be 1/3 of that cube. Because again, that's what the equation calls for, 1/3 base times height. but they are asking us not what is the volume of the cube, or not what is the volume of the pyramid. They're asking what is the volume of the marble removed. So they want us to write it as an expression. So it's not going to be 2/3. It's going to be, sorry, it's not going to be 1/3. It's going to be 2/3. Started saying the answer instead of what I was trying to say there. So again, 1/3 will be what is left over for the pyramid. 2/3 is what's being removed. So 2/3 t cubed feet cubed. That would be our answer. Again, it's what's being removed, so not what was left that time. On number 16, it says a company cuts 2 inches from the top of the solid plastic cones. How much less plastic is used in the new design? So on here, if they're cutting off the top of this plastic cone, well, we're removing a cone from the cone. This is going to be a composite figure. And again, we're just subtracting. So we're taking the volume of the big cone minus volume of the little cone. So we're essentially doing volume of the big cone. So we're doing the 1/3 base times height minus 1/3. Now I'm going to make the B and H lowercase just so we understand that we're doing the big cone minus the little cone. So base area, let's go ahead and figure out the base area separately here. This one, we're going to do pi r squared, and pi r squared here for this big cone, pi 21 squared. 21 squared is 441. I'm leaving it in terms of pi until the end. So that's for that big base. For the little base, we're going to do the same thing. So pi, the radius on the little one is 3.5 squared. So 3.5 squared, that's 12.25. Oops, supposed to be pi. All right, so now plug them in. 1/3, the area of the big base there, 441 pi, times the height of the entire thing. And that's where this gets tricky. This 10, since they put it here and it's broken up into 2 pieces, we have to recognize this 10 is only for this piece. The entire height of the big cone, we have to add that 2 to it. So it's going to be 12 for the height of the entire thing. Again, the whole thing is 12. And then subtract off the volume of the little cone. Volume of the little cone, 1/3. Base area of the little cone was the 12.25 pi. And the height is 2 times 2. All right. That almost didn't fit on the screen. So we have 12 times 441 divided by 3. Again, I'm still leaving things in terms of pi for right now. So I have 1,764 pi. And then I have the 12.25 times 2 divided by 3. Again, still leaving this in terms of pi for right now. 0.16 continuous. Now, let's go ahead and get rid of the pi because again, it wanted us, now they didn't actually give us any rounding directions for this one. So really we could leave this in terms of pi still. It's up to you. They didn't say how they wanted their final answer because the directions up at the top were only for 13 and 14. So if you wanted to leave this in terms of pi, you could. I'm going to go ahead and change it out now. So let's go ahead and subtract these. So I have 1764 minus that 8.166 That's going to give us 17,5,5,8,3 continuous times pi. And we're multiplying by pi, so I'm going to multiply by 3.14 just so I can get a rounded answer. 5,513.36. And this is in inches cubed because it's a volume. That seems like an awful lot. Bum, 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 bum. You know what? Did I answer the actual question? It's always good to go back and read the question because that's what I do anytime I answer a question is go back and read it. I just realized I made a very common mistake. I did this entire problem. I answered what I thought it was asking for, but did I answer the question? I do have the correct answer up there somewhere, but my current answer is wrong. Can somebody tell me what is the correct answer here? Because it is on here somewhere. Anybody paying attention anymore? I got nothing in chat here. I think everybody just has me going and is off watching TV or texting or something else. Anybody want to take a guess? What is the answer? It's up here. All right, no takers. Oh, wait, let's see. No. Thank you for guessing, Major. That's not it. Luke, you are close. So Luke said 8.16, which is here, but you gotta make sure you include the pi with it. So 8.16 pi, that would be the correct answer. Or again, you'd have to multiply that out if you wanted it not in terms of pi, but 8.16 times 3.14 is 25.62. So the reason why that's the correct answer, and let me write it over here as just a final value somewhere. I'll try to write it sideways. 25.62224 is our final answer. And that's from over here because it did not ask for the volume of the cone. I thought it was asking for how much plastic do we need to make the cone. Because I thought it looked like, hey, we're taking the figure, we're subtracting off that top piece, finding what's left. But if you read the question again, it actually says how much less plastic is used in a new design. So what do they actually need us to find? They only need us to find the volume of the top cone. This piece here. They gave us all this other information to throw us off. So it's very important you read the question and make sure that you're answering the question that's being given instead of what you think it might be. Because again, I did a little bit of extra work there, but again, it doesn't hurt because you might have a composite figure on the test. All right, let's keep going. So spheres, all right. We had a formula for our volume of a sphere and volume of a hemisphere. Those were two separate formulas. Again, it's 4/3 pi r cubed and 2/3 pi r cubed are two formulas that we're using here. For the first part of this, it says find the volume of each figure round to the nearest tenth. Again, it's just a matter of plugging into those formulas. So for number 17, there's not a whole lot of work to do on this. You just got to make sure you plug in the right number because the number they give you isn't the one you're supposed to use. Because that's the diameter. The radius is only 1.2. Same thing on the other figure here. The radius is only 0.9. So just be careful. Make sure you use the radius and not the diameter when plugging into this. It's very easy to use the wrong number when plugging into these equations. So on 17, again, we're doing the volume of the sphere. So this is the 4/3 pi r, which the radius on there was 1.2 cubed. For number 18, it's a hemisphere, so we're going to be doing the 2/3. Pi r, which was 0.9, cubed. Again, make sure you put the decimals in the right places when you're doing these. Make sure you multiply everything out correctly. But really, again, just plug it into your calculator for these because it's telling you round to the nearest tenth. If it's a leave your answer in terms of pi, I'd probably do a lot of the work without the calculator. But since it's telling us to round, I'm going to plug it in. And if I ask you to do that on the test, I'm going to tell you to use 3.14 for pi. Like I said before, I'm not going to ask you to use the pi button on the calculator. So we have 4/3 pi. So I'm going to do 1.2 cubed times 3.14 times 4, because that's on the top of the fraction, and then divided by 3, because that's on the bottom of the fraction. So our answer on the top one should be, if you plug it in correctly, 7.23456 inches cubic. On the second one, again, plugging it all in, I'm doing the 0.9 cubed. Then we're doing times 3.14 for pi times 2, and then again, divided by 3. So if you plug everything correctly into the calculator for this one, you should get 1.52604 centimeters cubed. Now, are those our final answers? No, because again, they want us to round to the nearest tenth. So we need to round both those off. So on the first one, that should round off to just 7.2 inches cubed. On number 18, that one should round off to 1.5 centimeters cubed. All right, on number 19, a golf ball has a radius of r centimeters. What is the least possible volume of a rectangular box that can hold 2 golf balls? All right, so they want the least possible volume for a rectangular box that can hold 2 golf balls. So they need us to figure out the dimensions of this container. So if we picture this, we have this is not going to be the best picture since I'm using a tablet to draw this. I can normally draw these much better, but we have 2 golf balls sitting on top of each other. So what dimension of that golf ball is actually giving us the dimensions for the container? It's the diameter of the golf balls, because you're going to need the diameter as your width, both your width and depth there, and then you need your diameter doubled to give you that height. So we're going to have to find that diameter of the golf ball in order to figure this out. So they told us a golf ball has a radius of r centimeters. So they didn't even give us a dimension here. We just have to figure it out based on r. Well, if we know that r is representing our radius, then our diameter would be 2 times r. So if we were looking at the box, our dimensions, 2 will be 2r, 2r, and then the other one, you have them stacked on top of each other, so you're going to have 4r. 2r, 2r, and 4r multiplied together to give us, see, 2 times 2 is 4, 4 times 4 is 16, so 16 r cubed. This equation would give us the volume of the box that can hold the golf balls. On number 20, a capsule of liquid cold medicine is shown. If one dose is about 23 milliliters, how many capsules make up one dose? So They gave us the dimensions, and they also told us that 1 milliliter is 1 cubic centimeter, which is correct. So we are going to take the dimensions there and figure out the volume of this. Now, things to keep in mind. We have 2 hemispheres and a cylinder making up the shape. So what do we actually need to find the volume of? We only have to find the volume of 1 sphere and 1 cylinder. Because again, the 2 hemispheres together are going to make 1 sphere. So for our formula, we could do volume equals the 1 sphere is 4/3 pi r cubed plus the volume of the cylinder is going to be found by doing the base area times the height, which again, for a cylinder, the area of the circle, so pi r squared times height of the cylinder. So we need to plug these values in. Well, do we have the radius of the cylinder? Yeah, it's the same as the sphere. So when we do this, we have 4/3. We're going to have to plug in pi for this, so 3.14. The radius is 1, so 1 cubed, plus 3.14 times the radius, which was 1, times the height, which was 0.5. So multiply this out. We are going to have, for the sphere, 4/3 times 3.14 times 1, because 1 cubed is just 1. So 3.14 times 4 divided by 3. So for the first part of this, 4.186. For the other part of it, 3.14 times 0.5. It's going to give us 1.57. Add those together. We get 5.756. So one dose is approximately or about 23. We need to divide 23 by that answer. So 23 divided by is roughly 4 capsules. Again, the way we got that, I took the 23 divided by 5.756, and it gave us 3.995, which is very close to 4. All right. Let's go one more. Oh, nope, that was it. So that was it for today. I went 5 minutes past, but not too bad for that entire review. Again, things to keep in mind. Let me flip back to the calendar because, again, I had some people join way late. So let me, again, remember you do need that formula, Euler's formula or Euler's law. You should have that reference sheet printed out when you do the test, or maybe on your phone as you do the test, something. For the test itself, I will open it up on Thursday. There will be a couple reviews posted on EDSB today, as well as some answers to those reviews. So make sure you check your answers. The Zoom that I'm doing on Wednesday will be going over any extra questions. So the last time we had a test, I didn't post the video from Wednesday's Zoom before the test because there were only a few questions and I didn't feel like it was necessary. So again, if you really have questions that you need answered that either A, weren't answered by the answer key, or B, weren't answered by the video that I'm going to post ahead of time of the answers, then come on the Zoom on Wednesday and ask me any questions. I'll still have my office hours on both Tuesday and Thursday as well. Friday, since the test will be open, again, I'll have regular office hours on there instead of a class. But again, if you have questions on any of the reviews, you can come on Tuesday through Friday, ask me questions about any of the reviews that I've given you up to this point or any of the other assignments. But this is the last full-length video that I'll be posting to YouTube. And then if you have any other questions, let me know. Have a good day. If anybody has any questions, I'll stick around for a minute to answer questions. That's the end of the lesson. Any questions? No. All right, I'm signing off. Have a good day.